said, the cost of structural steel, mostly structural, the steel structures consist major portion of the connections as well, because the labor mostly goes into joining the connections and the material which is provided there. So it has to be considered as a safety or the economy of structure. Connections are the devices. They are used to join elements of a structure together at a point such that the forces can be transferred between them safely. Historically, if you see in most of the cases, the structural failures happen due to some form of connection failure and at the junction. So the steel connections have a direct influence on the cost of framing system. While a connection may be efficient in the use of material, it may still be very expensive to erect. So many of the time, repetitive connection design also saves the cost. So now if we see the elements of steel connections, majorly they are bolts, rivets, the welding, then connecting plates and connecting angles. Again, the connecting plates and angles are connected with the bolt or by the riveting process or welding process. We'll see each of it in detail. So the classification, there are few types of classification which can happen according to the different criteria. First of them is on the basis of connecting medium. So which medium are we using to connect the junctions? There are majorly three of them: riveted connection, bolted connections, and welded connections. Bolted and welded is just the combination of two connections based on the requirement, if there is any, due to the members. So first of it is riveted connections. You must have seen these kind of connections for the steel bridges which are constructed like 40-50 years back, because the riveted connections are nowadays mostly obsolete. The understanding of this type of connection for the strength evaluation and rehabilitation of the older structure is essential. So that's why we are getting to know this connection. The connection type for the riveted connection is same as the bolted connection. I mean, the process of transferring load or the behavior of junction, it is same as riveted bolted connection. So the primary component of this connection is rivet. This is the typical rivet. Rivet is made up of a round ductile steel bar, which is also called a shank, and with a head at the one end. So this is shank, the middle portion, and this is rivet head. It is made up of mild steel or high tensile steel. So the process of riveting is conducted by inserting the ductile metal pin or rivet into the holes of pieces to be joined together, and formed a head at the end of the rivet to prevent each metal piece from coming out. The shank of the rivet is made up of the length to the extent through the different parts which is to be connected, and with sufficient extra length for a second head to be made. So in this process, what we generally do, we insert this pin. While inserting this, we actually heat the rivet at very high temperature, and then we insert it through the holes in two metal pieces or two members, and then we hammer the second portion and create a head on the other side so that it fixes the two components. There are so as you can see in this image, the rivets which are being placed to connect. These are again in the image, this is built up section. So there is there are metal plates which are connected with each other by on site, and since the size is very large, they are not created in the workshop or factory. So there are mainly two types of rivets based on its pattern. Chain riveting, which is the first example, and another one is diamond riveting, this last one. So, or also known as zigzag. I mean, the position of hole is not in a single line or a single row, but it is zigzag. This plays an important role in creating a tier path. That you'll know when we'll do some numericals later on, maybe when Bhargav joins. But for now, just understand the two patterns. Advantages of rivet connections are they are used for heavy duty steel structures. They were used for heavy duty steel structures due to their high toughness. Uh, disadvantages for this is that it creates very high level of noise pollution while constructing it, because each rivet has to be hammered, and that is like creates a noise pollution. There is a need to heat the rivet with red hot color. I mean, it creates a lots of heat to just before the inserting it to the hole. So again, it requires a labor in that sense. Skilled labors are necessary to inspect the connection. Even to fix the rivet, the skilled labors are required. The cost to remove the poorly installed rivet is very high. The high cost installation in the connections as well, the whole assembly, if you see, that also costs higher than the regular bolted connection or the welded connection. So that's why again this is not preferred nowadays. And the next connection is bolted connection. Most commonly used connections include this, like many maximum construction happens with these bolted connection. So this connection has the advantage of flexibility in assembling parts of the structure as well as disassembling it, and which is necessary if there is inspection or some routine maintenance work. This type of connection is applicable for members subjected to tension or shear, or both tension and shear. This we'll see on the behavior of forces for connection later on the later slide. Bolt, if you see, a bolt is a metal pin, just like the rivet, but with a head formed at one end and shank has threads around it, like a screw, if you see, so that nut can be received, so that the other side can be fixed with the nuts. Generally, the bolts are used to connect pieces of metal by inserting them through holes in the metal, and at the threaded end, nuts should be tightened. That is generally done by the machines, and not the machine, but the different kind of a driller. On the right side, you can see in the image the position of rivets, bolts has been marked, and then they are drilled and they are connected with the metal plate. And this junction has been made. There are column, there are braces, and they are connected with the connecting plate, which might have been connected to the beam at the bottom, which we are not able to see due to reinforcement. Again, in this image, the primary and secondary beams are connected with the bracing, different type of bracing, to the column and making a unified joint. So the advantages of these joints is that the process of erection of structure can be made faster compared to the rivets. Skilled labor is not necessary, since if a person is taught the basic of fixing the rivets, then he can continue doing it repetitively. Connections do not involve the noise as it happens in rivets. The requirement of labor is less. Immediately we can use the structure in case of bolted connection. In rivets, as I said, we almost melt, not melt, but heat up at a very high level and then fix it in the connection. So we have to let it cool down, and then we have to inspect the connections in terms of rivets, and then it can be certified to use. But in bolts, once it is fixed, it can be used immediately. The alternative arrangement of structural members is also possible if required. Like we can easily remove the nuts and change the structure if at all required later on, and it is easy compared to rivets. Lesser working area is required since there is only a person with the rivets and it is and he is fixing it. It does not require any heating mechanism or such like rivets. Again, the material cost is very high with this, and due to area reduction at the root of the thread and due to concentration of stress, the tensile strength of this type of connection is reduced. Since the diameter of the bolt is going to remain same, but at the while we uh, thread the bolt, so we remove some part of it to create those spherical threading. So again, that reduces the area somewhat, and it affects the integrity of the connection. So that's the thing. And also due to the any seismic loads like vibrations due to earthquake or shocks or maybe in industry or factory, uh, there is a possibility of the bolts getting loose. It doesn't mean that it will, due to very small intensity of earthquake, the structure will disassemble. But still, there is a possibility if the bolting is not done properly, there is a possibility of bolt getting loose. So that has to be that's the difference between the rivet and bolt. Now, if you see the types of bolt which are available, first you can see this the all the components of bolt, nut and bolt. So this is the head, hexagonal head. This is the shank, which is as wide as the length of the connection we require, which is known as grip portion. This is the washer. If you can see in this image, this circular thing, flat circular thing is washer. This is nut, and the portion with spherical threading is this. So now there are four types of bolts. Uh, in terms of image or in terms of components, it seems to be same, but the material and strength of it differs. Based on that, these are the types. The first is black bolts or unfinished bolts. These bolts are made of mild steel, and they are generally used for light structures under static load, such as small trusses or purlins, etc. Not We don't make them experience heavy loading or main structural elements to be connected with these bolts. Black bolts have adequate strength and ductility when used properly, but while tightening, the nut snug tight will twist off easily if tightened too much. So if you give it the torque more than what is required, the it might twist off if we tighten it too much. So that's why it is used for light structures, small structures, and not the main structural elements in the building. Then the second is turn bolts. These are similar to unfinished bolts, with the differences that the shank of these bolts are formed from a hexagonal rod. So as you can see the shape of it, the top shape, which is hexagon. The surfaces of the bolts are prepared carefully and are machined to fit in the hole. Tolerance allowed are very small in these. These are basically more precise than the black bolts. These bolts have high shear and bearing resistance as compared to the black bolts. Again, the difference in material makes it better. However, again, these bolts are obsolete nowadays. Now we have more developed, better, having high shear resistance. So these are again not much used. Then the third type is ribbed bolts. So this image is of a ribbed bolt. The head of this bolt is like a rivet head. The threading and nut are provided on the other end of the shank. on this end. From the shank core, longitudinal ribs project, making the diameter of shank more than the diameter of the hole. So as you can see, the diameter near the threading area is less than the ribbed area, which is this portion. So these ribs have more resistance to vibration as compared to ordinary bolts. Because the holes in the metal plates or metal elements are generally of the smaller diameter. So in that we try to fit a larger diameter so that it, due to the friction, it can hold and sustain the connection. Then the fourth type is high strength friction grip bolts, which is largely used for steel structures, steel connections. They are also known as HSFG, provide extremely efficient connection and perform well under fluctuating or fatigue load conditions. So again, if you see the railway bridges or maybe roads which are built by the steel girders, there the dead load is there already, but also there are loads of train passing by. So the cycling of the loading changes. So due to that, still it doesn't fail under these conditions. These bolts should be tightened to their proof loads and required hardened washers to distribute the load under the bolt heads. So as again I mentioned this, these are the washers. The washers are usually tapered when used on rolled steel section. The tension in the bolt ensures that no slip takes place under working conditions, and so the load transmission from plate to the bolt is through friction and not by bearing. So as we tighten the nut, it tries to after it reaches the width of the metal pieces, if we still try to give it a torque, it will create a tension in the bolt, which helps this friction helps to uh, transfer the load from plate to bolt. So due to that, it has a higher shear resistance. It won't like slice off due to the shear force or the loading. Then there is a third type, which is welded connections. So welded connections are direct and efficient means of transferring forces from one member to adjacent member. Welded connections are generally made by metal base plate connecting with the welding metal. So if you can see here, the metal from the member, which is connected with the metal which we use to weld, and when it gets cooled, it creates a unified homogeneous connection. So structural welding is the process by which the metal parts that are to be connected are heated and fused. Advantages of these connections is that it offers air and watertight joints, and it creates a very rigid joint. Comparatively, these are lighter than rivet and bolted joints. As you can see, when we are using bolts, there is a extra material used for bolts, the nuts, the washers, and if you see in the previous image, if you see that the or if there is these rivets at all the junctions, the weight of these rivets also will be will that we might not be able to negate. So that is reduced while welding these connections. It is, of course, since the material is getting used lesser, it is more economical, the welding connection. Also, the fabrication of complex member is easy. Since we are just joining two material, we don't, the process behind designing a rivet conditions or bolted connections is also significant. So by this, it gets reduced. Even we have to decide where each hole has to be drilled into the section so that we'll be able to make a proper connection. So with welding, that process is not coming into the picture. But of course, we do have to design the welding conditions and the area of which it is going to get connected then the material which is going to be used for welding, also how much deep is the weld, because when we are welding this connections, the heat is about 4000 3000 to 4000 Celsius. So at that level we don't want to puncture through, or maybe reduce the thickness of material by melting too much of the metal. So that's why it is also necessary while how we design the welding condition. As you can see in this picture, everything is decided by the engineer, how deep this connection is going to be, how much material is going to be coming on the metal, etc. So the disadvantage of this connection is that it is very stiff and very rigid compared to the rivets and bolts, because there is some space for flexibility in those connections. Not literally, but there is some ductility in those materials. Here we are making it a unified metal piece, so which might lead to deformation in joints later, at later stage. Again, there are no provision for expansion or contraction. Therefore, cracks may occur easily in the condition where temperature changes frequently from high to lower. The joint is more likely to get affected in low temperature. Again, the same reason. And the inspection of these connections is also costlier, because in rivets, it's easy to observe if the condition of bolts or rivets or at every junction. But in welding, it's visually not. Visually we can't inspect these connections. Uh, okay. Again, the advantage of welding connection is, if you see in the third image, since the column is circular, maybe hollow circular tube, to connect metal plates to this column, it is difficult to create these circular plates and bolt it. Or so that's why welding connection is better in these kind of conditions. Then there are different types of welds, like groove. As you, if you are connecting creating a butt joint of two plates or two members, when we are welding it, we create a groove and then fill up the material by welding and create a homogeneous joint. Fillet is generally used for angles or corners. So if we are not providing butt joint, then we might provide lap joint, in which on the corners we can provide welding. Again, the T junction, corner junction, all these way we can uh, create fillet weld. Then plug joint. So this is not mostly used because it has low resistance compared to the fillet and groove joints. So in plug joint, generally the bottom plate is connected to the top plate by creating a void in top plate and inserting the material into that created area and creating a homogeneous joint. In slot, it is modified way of plug, where we create a longer voids so that the connected area is more, and it creates a better joint. Then there are types and positions of welds. So like again, flat or horizontal members or vertical members or overhead members. So this is just for your reference. It is just to explain you the uh, connections as per their position during welding, how it is getting joined for edges. For it creates a difference when it because when the laborers are working on site, how it is going to get connected. Accordingly, they have to assemble the pieces on site and create a sequence of them. That's why it's important to just know these conditions. Then there is a classification of connections according to the internal forces the connection are expected to transmit. So one of the most important consideration is this, because uh, it is based on the internal forces of connection. Connection are classified as axial connection, shear or semi-rigid connection, and the third is moment or rigid connection based on the primary load that the connection is going to carry. Uh, Connection, however, are most typically expected to carry more than single loads, but the primary loads on which we divide those connections in these categories. So the first one is axial connection. It is also known as splices. Axial connections primarily carry axial loads and include splices, bracing, truss connection, or hangers. They are typically used to connect column to column or beam to beam, sometimes maybe of different sizes. Uh, it is often required to join structural members like beam or column along their length due to the available length of sections being limited in the market, and also due to transportation and erection constraints. So such joints are called splices. Uh, Typically, as we saw in the bolted connection also, if you see in the image, these two members are connected via riveting and have created a splice. Here you can see in column to column connection, they've used metal plate with the rivets to create, with the bolts to create a column splice, and this is a beam splice. So this is how it acts. It joins the member along its length, and it carries axial load, mostly the load which is going to transfer through its axis. For column, it is vertical. For beam, it is horizontal, passing through its CG. So it transfers those loads into each other and uh, creates a structure. Then there are shear connections or semi-rigid connections. Shear connections primarily carry shear loading, although they typically also carry axial loads, but the primary function is to resist the shear force which is passing through it. They are the most common type of structural steel connection and are referred to as simple or semi-rigid connection, uh, which includes uh, plates or web angles, angles connected to the web to the column, this image, or seat angles. This connection transfers shear forces to the connecting members, thus, like if you thus allowing the end rotation of the member. Shear connections may be made to the web of the supported member while the flanges remain unconnected. If you see in this I section, the flanges are not connected, due to which uh, if you uh, picture in your mind the typical column beam connection in any material, there is going to be moment at the junction. So by connecting only the web, it the this moment may act upon on this member, due to which this is the slightly exaggerated image, but it is also, it may, like we understand the types of supports, it can also be categorized as the pin joint. So there won't be any shear, it resists it, but there might be moment which we might not be able to resist. So it allows end rotation of the member. Then comes the moment connection, which is rigid connection. Moment connections primarily carry moment loading. However, again, these are like a fixed end condition which we learned in last year. So they carry axial loading, they resist the shear loading, and also they resist the moment which is getting created in the beams. So If you see this image, it is again exaggerated. It doesn't happen like this when deformation happens. But in this condition, we also connect the flanges to the main structure. So they usually designed to resist shear and axial loading as well. For this reason, they are referred to as rigid or fully restrained connections and are used to create a frame. Uh, Common moment connection include directly welded members, flange plates, and end plate conditions. This connection carries a portion of full moment capacity of the supported member, thus preventing any end rotation of the member and also carry the shear component of the load. The relative rotation between the supporting and supported member is negligible. In this type of connection, both web and flanges are connected compared to what we saw in shear connection. Then another type of classification of these connections based on the members which are getting connected. Guys, if you have any questions, any query, any doubts, you can unmute yourself and interrupt me. No issues. Okay, the classification of steel connection is also commonly made in the structural members that they are to connect. In fact, the consideration for connecting columns and beams should act as one of the primary consideration when needing to design a steel connection. The common configuration includes the beam to beam connection, which we know, which we discussed as splice connection, is also part of this. So there are generally two types in this beam to beam connections. Depending on the beam geometry. The first type is the primary beam connected to the adjacent secondary beam. As we know, sometimes we connect the, like we have learned in the single story, double story connections in wooden structure. Even Jimmy discussed it last time. Same way, if we are connecting primary beam to the secondary beam, this condition is called beam to beam connection and it can be categorized into that. Then there is also a requirement for beam to beam connection when it is at the same level. Still it has to the primary beam is passing through the longer span and the secondary ribbed beams are connected, or maybe they are used for floors, so they are getting connected by the base plate, not the base plate, the metal plate, connecting connector plate and the beam. And this, as we saw earlier, this is the splice where two longer members are two shorter members are connected to create one longer member due to unavailability in market, maybe, or maybe due to transportation also. So if you can see, the flat plates are from in front and in behind, they are connected with the rivets or bolts. They can also be achieved, this can also be achieved by welding. Then another type is column to column connection or column splices. If we see this, these are usually accomplished with the use of a column splice. A common application for this is when we are using different cross sections. Then we require them to get connected and transferred through load by distributing properly. So on the, if I don't think there is an image here in with the different cross section, but if the larger cross section is at the bottom, then we provide a flat plate over it, and then the smaller section is fixed on that flat plate, so that the smaller section distributes to the plate, and plate then again redistributes it to the high section below. These are again circular sections or square hollow sections which are getting connected with this thing. In these type of members, these plates are already the circular plates or the square plates with the drills. They are already factory made, or they are constructed at the manufacturer's place. Generally, you might have seen these for water pipes, I guess, the circular thing. Then in these, third type is beam to column connection again. So there are shop welded clits available. I mean, they already weld these clits to the beam so that you just have to fix it to the column on site, and you don't have to again separately connect these angles to the flanges. Then there is a connection by using the end plates to the flanges. Then double angle web plates on both sides, they're getting connected. And seating angles, they're again just the basic types. Beam to column connections are the most common type of member configuration. So with the column acting as a supporting or a parent member, and the beam acting as the supported member in the adjacent in an adjacent orientation. And the last type is column base plate connections. So from column to the base, generally we use RCC pedestal, which is connected to the RCC foundation, and it transfers the load to the ground. Due to the low resistance of metal to water or any other chemicals, we use RCC foundations generally. There are steel foundations which people have used before, but generally it is expensive to use, and again it doesn't provide the resistivity which is required. So we create a RCC pedestal which comes a bit above the ground, and then we use base plate. We connect base plate to it and the column or uh, further members to it. Column base plate, so the typical consideration include the size of and thickness of the plate. Since it is going to carry the load of the whole structure, there shouldn't be any punching shear. So we have to keep that in mind. As well as the grouting for the leveling of the plate. Again, slightest even the difference in the level of this plate, uh, the structure might tilt as you go above. Like the further connections which are pre-designed in digitally, they might not be able to get executed on site if there is a slightest of the difference in the level or even in the distance of the connections. So that has to be considered, and it has to be properly leveled with the grouting. Anchor bolts, we generally use anchor bolts to install this to the concrete pedestal, connecting the base plate so that uplift can be restricted during erection. So these anchor bolts are fixed into the concrete, which you might know the anchor bolt expands at the end. So after getting inserted into the concrete base, the bottom portion of the bolt expands so that it cannot come out of the concrete block. So these anchor fasteners are used, and again on here you can see again our regular bolting process is used to connect this. So this is pretty much it about the connections. There are going to be numericals and the design of these connections, which I hope Bhargav joins soon so that we can go through them as well.
Hello, Neeraj.
Uh, s- yeah, yeah.
In the last slide,
Hmm.
what is double angle web plate? Like, is it similar to L angles or is it
L
different?
angle, yeah, yeah.
It is L angles.
Yeah, it's similar to that.
So I had a doubt. Could
Yeah,
you give some like examples of where shear or semi-rigid joints are used? Like if the moment is not zero, but the shear resistance is zero, like where could that be used?
correct, correct. Okay, so we might you might have learned the support conditions in second year, like pin joint, hinge joint, or rigid joint. So same as that, if we see some the connection, let's say in a structure, the connection at the this column to base That is very primary thing where we does not require any flexibility. So there we might be using the fixed or rigid connection. But sometimes in earthquake prone areas, or where there are supposed to be vibrations involved after the for the function of that space, we don't want those connection to be rigid. As we saw, if there is a rigidity, then it won't uh, the integrity of the joint might be reduced due to the vibration. And the joints, if we make it a rigid, there are chances of cracks developing in the welding, or maybe the bolts getting loose, or those kind of things. So basically, it is again on the design, where we are designing and how rigid we want the joint. If we don't want to resist the moment and we want that some flexibility there, then we won't be joining it with the moment connection. Uh, Moment connection, yeah. Like even if you see many of the time in metal construction, or even the railway, those railway tracks, we always give some expansion joints for maybe for heat, or maybe due to vibration, so that it can negate the type of loading some amount. So it depends the condition of joint, uh, maybe due to on the site, or maybe the how flexibility is required at the junction. So accordingly, yeah. I hope that answers your question.
Yeah, thank you.
Welcome. So any other questions, guys,
Yes, I
from
have
any
one.
slide? Hmm. Yeah.
So even after welding, why is there need for bolting or riveting about that?
No, if we see, if we weld it, then we don't require bolts. So in this image, if you see, what they have done here is they have welded this plate, the clit which you see, the rectangular clit. It is welded to the eye section or eye column, but the welding is not done to connect the web to this column in this particular image. They what I hope you're talking about this image particularly, where you
Yeah.
can see both the things. Yeah. So here the beam is connected uh, with web to the column via this clit, which is bolted, and the top portion is welded. I think I made you confused with this image. I might have used something other, but still okay, no issue. So this clit, so what happens is on site you can't do everything, because if you pre-install this clit to the column uh, in the factory, or maybe you can bolt this clit to this girder in factory, and you just have to on site you just have to weld this, then it would be easier and less time consuming. So that's why there are various, like this is again depends on site and the time frame and the project, how you are managing this assembly. So that's why they might have they might have done these connection before in the factory and then welding on the site. So the both things are not used. It is just the connecting to the middle member. That's it. It's just
Okay.
to connect the middle
And
member. Yeah.
yeah. And for longer spans, which one of
Hmm.
these connections are usually used, like welding, bolting, or riveting? Which one is
Generally, we use bolting. Riveting is not much used nowadays because see, the function of rivet and bolt is the same, but the process. Acha, haan, just a second. I would like to show you the process of riveting and bolting. Then you will understand the thing. Just- Can you see the video? I mean the. Okay.
yes?
I don't think you might be able to hear, but that's okay. Like, see, the base plate are getting placed, and these connector plates are fixed on bottom and above. Now he is fixing it. See, this is the washer which I was talking about. It is thick. It has to resist the pressure from nut to the. These are again high strength friction grips bolts. So this is done in the. This video is done just for the exam in some lab or workshop, I guess. Guys, is it smoothly? The video is smooth or is it freezing in between?
It is
It's
freezing.
not smooth.
Acha, okay, no issues. It's okay. Just see this for now. I'll upload it in the file so that you can just refer it later on. But you might be able to see the glimpse of it. He's just inserting the bolts and putting the nut over it in all the holes. The answer to that question is that generally the riveting is the best option for the high strength construction where it is required, because the development in this is done pretty much very better, and also the maintenance of these connections is the bolting connections is easier than the welded connection, because in welding then you have to scrape out the whole welding, you have to re-weld everything, but in riveting you can just change an individual rivet if there is anything, and the work has been done. So that's why that riveting is no, bolting is most preferred uh, connection used nowadays. But to connect the secondary beam or the smaller members, they are generally welded on site. But the primary connections are used. They use bolting. So he's manually tightening it a bit, and now with the mechanical driller, they will give them the amount of torque which is required. You can't connect it. I mean, you can't give it more torque or lesser torque. It has to be uh, given in the exact amount. Also, if you see in the image, these bolts have ribs on at the end. This is these ribs are used to get fixed in the driller, like to make them tight. These are getting used in the driller, and then they are getting chipped off by the machine itself. So otherwise, to do this manually, you won't be able to manage the pressure and the torque. So, acha. Now this second video is of riveting. You see, there is a thing required to heat up the bolt, apna rivet. Sorry, there are more labor required. There are experienced labor required for this, so that they can hammer it. See, this is the bolt, apna rivet. Sorry. They are inserting it inside. Still, they are giving the heat to it so that it doesn't get cooled off. Constant heat is required. So again, safety concerns are there. So from the hole, they've inserted this rivet. See the flat head of the rivet, and then they use this mechanical hammer to give this shape of the rivet, and then it is they let it cool off. So again, if you can imagine the maintenance, again to check and inspect this rivets and to replace it, you will require skilled labor in this amount, and it's a bit complicated. So the best this practice is to use the rivets. Sorry, bolts. Yeah. So, is there any more questions? If not, then I'll just take the attendance and we'll see next time what we can take. Hopefully, Bhargav will join. So we'll start with the theoretical part of this semester. Okay, so bye, guys.